Okay, 4-point charges. No, actually, I'll give you a moment. Pause this, read the problem, find it and read it, and then unpause it. Alrighty, so let me recreate this real quickly. So let's say the top left, I'll use this teal color, and that's positive Q. And the bottom left, I'll use a blue color, and so that's negative Q. And let's see, something that stands out clearly. Bottom right charge, that's also positive Q. And then this one up here, one that's, we're wondering what's the direction of the resulting force acting on it, that's also negative Q. Okay. Well, so let's consider, since it's a square, let's say the length of any side is S. So this is S, and this is S, and this is S, and that is S. Okay. So the force, due to the positive Q here, acting on the negative Q, will be an attracting force, so it's going to pull it in this direction. And that teal force will equal K times Q squared divided by S squared. Okay, and it will be going to the left. The force due to the bottom right charge will be the same because it's the same two quantities and the same distance. So this force, due to this red one, is going to be downward, and it's going to equal K Q squared over S squared. Okay. Now, for the two negative charges, the first thing we need to realize is that the distance between them is the hypotenuse of a equilateral right triangle. So this is S times the square root of 2. If you don't remember that, just use the Pythagorean theorem and you'll get that value for the hypotenuse, or this diagonal, which is the same. So that means that the force due to these two is going to be, well, firstly, they're both negative, so it's going to be a repelling force. So it's going to go this way, along that line. And it is going to be, well, let's see here. So force equals KQ squared over, now the distance is S times the square root of 2. So S times the square root of 2 squared, which is KQ squared over, now S squared and the square root of 2 squared is 2. So that's the same as 1/2 of KQ squared over S squared, which is 1/2 of these F. So I've defined F as just KQ squared over S squared. So this is 1/2 that. So this is half the strength of either of these two. Okay. Now, what we need to do is consider the last arrow choice that we have, and that's one going this way. This is going to be the sum of all of these plus this guy. Now let's just let the orange one be the vector sum of teal and red. Since these are both the same magnitude, we can use the Pythagorean theorem. So the orange force is equal to the square root. Now the teal is F, so it's F squared, and the red is F, so plus F squared. So that's going to equal the square root of 2F squared, which is F times the square root of 2, bringing that out, which is, the square root of 2 is about 1.4. It's 1.414, etc. So it's 1.4F. All right. Each of these is f, but they combine to give me 1.14f. Half f is in the opposite direction. So what direction would the net force be? Because all we have to do is compare the orange and the blue. Well, it's got to be this one right here. And I think according to the diagram that that's choice B. So it's got to be vector B. Here, let's bring the original back now. So vector B, which is going to be, well, what would it be? It would be 1.4f minus 0.5f. So it would be 0.9f. Okay,